In our last session, we explored adding like fractions, that's those fractions that have the same denominator. And we're going to just go back over that last lesson with the last question, just to review what we know. So Richard thinks that 1/5 plus 1/5 equals 2/10. And he thinks this because 1 plus 1 equals 2, and 5 plus 5 equals 10. Jamila, however, thinks that 1/5 plus 1/5 equals 2/5. So the question here is, who is correct? And when you're answering that, I want you to explain how to add fractions with the same denominator to prove that you're correct with your thinking. So Richard thinks that 1/5 plus 1/5 is 2/10 because 1 plus 1 equals 2 and 5 plus 5 equals 10, while Jamila thinks that 1/5 plus 1/5 equals 2/5. So who is correct? Pause the video, work this out, and come and join me when you're ready to look at the answer. So let's take Richard's opinion first to see how this works. So Richard thinks that 1/5 plus 1/5 equals 2/10 because 1 plus 1 equals 2 and 5 plus 5 equals 10. And I'm going to use a bar model to check whether this is going to be correct. So using Richard's explanation, I've done two bar models of fifths and a bar model of tenths, which is going to be my answer. Now notice how all my bar models are exactly the same length because one whole is always going to be one whole, and the fractions that we're going to be working off is going to be from that one whole. So firstly, I've highlighted those two 1/5s that I'm going to be adding together, so the red 1/5 and the green 1/5. And now what I'm going to do is I'm going to highlight my 2/10 on the bar model below. And now we can see I've highlighted those two parts onto my 10th part, so I've got 2/10 that are highlighted. But if we look at the bar models now, we can see that the problem I've got is 1/5 is exactly the same as 2/10. So I can't have 1/5 and 1/5, which actually makes the same amount as just one part, because if I'm adding, I'm always going to make a bigger number, a bigger amount. So it can't be 1/5 plus 1/5 equals 2/10, because 2/10 is equivalent to 1/5. However, if I take Jamila's point, I've got my 1/5 and my 1/5. So what I'm going to do is I'm going to move both these down. So I have 1/5 in my new bar. I'm going to take my other fifth and place that 1/5 in this bar, which we can see is definitely bigger than 1/5 now. But it's 2/5. So we've got 1/5 and 1/5 equals 2/5 because our denominator isn't going to change. We're basically saying I've got one of 5 parts and then another one of 5 parts. If I put those together, then I've got 2 of the 5 parts. It doesn't matter how many of those I have, my denominator is always going to be the same. So when you're thinking about solving these problems, think about that bar model, shading your first 1/5, and then on that next very same bar model, shading your second fifth, because then that will be able to show you what you're working with. And that will work whether you're working with proper fractions, which means it's less than 1, or improper fractions, which means the fraction is going to be greater than 1. So now we've recapped on our last session where we looked at adding like fractions. Today we're going to be looking at answering the question of how do I subtract like fractions. Remember, we're going to be subtracting these fractions and the denominator is going to be the same. That's what the like fractions mean. So let's turn to our textbook and look at our first problem. And these all relate to our spaceship and this idea for fuel. With question 1a asking, how much fuel will be left after the journey home? So in order to start answering this question, the first thing is, how much fuel do we actually have at the moment? What can we see when we look at the fuel gauge on the dashboard? Then what information does it tell us about how much fuel will actually be used on this journey home? Is there anything on that screen that will help us to be able to do it? So do you think there's going to be more fuel or less fuel? And what's that going to tell us about the strategy that we need to use, the way that we can do this? And when we look at question 1b, we're asked if the fuel was full before the journey home, what would the answer be? So we can use exactly the same method, exactly the same strategy, but this time we're thinking that the fuel is going to be full. So be thinking again what that gauge would look like and how we're going to do that. Will there be more fuel? Will there be less fuel? What strategy will you be able to use? So for our first question, for question 1a, you're going to be answering how much fuel will be left after the journey home based on the amount of fuel we have right now. And for question 1b, if the fuel was full before the journey home, what would the answer be then? So Work out both those questions and come and join me when you're ready to discuss the strategy. So now you're back, let's have a look at what methods we could use to answer question 1A. How much fuel will be left after the journey home? And the first bit of information that we're going to look at is how much fuel do they actually have. Well, in this case we can see that there's 8 parts to our fuel gauge, and out of those 8 parts we have 1, 2, 3, 4, 5 parts of them shaded in, so 5 of 8 parts, or 5/8. And we know that there's going to be 3/8 that are going to be used on the way. If it's going to be used, we know that's going to be less, so that means we're going to expect to have it a smaller amount at the end. So we're going to be using subtraction. We're going to be counting back for this. So with this, I'm going to use my fuel gauge as a bar model, and I have my 5/8 highlighted green. I'm simply going to cross off 3 of them. That's 1/8, 2/8, 3/8. And we can see here that I've got 2/8 that are left. Should I choose, I could use my bar model to do exactly the same thing. I've got 5/8 highlighted on my bar, and I'm simply going to cross out 3 of those 8s to leave me with 2/8. But what would happen if I was to use my number line like I've done with my addition previously? Again, I'm going to start with my 5/8 and I'm going to count back 1/8, 2/8, and 3/8 to give me an answer of 2/8 once more. So no matter what method I'm using, as long as I'm counting back in those unit fractions of 1/8, 1/8, 1/8 to make 3/8, I'm always going to have 5/8 take away 3/8 equals 2/8. So let's have a look at question 1B. If the fuel was full before the journey home, what would the answer be? So if the fuel was full and the journey home uses 3/8 of a tank of fuel, how much fuel would I have left? Using my fuel gauge, you can see the whole thing is green this time. 8/8 are coloured in. 8 of those 8 parts, which equals the whole. And what I'm going to do is I'm going to remove 3 of those 8s by simply crossing them out. 1/8, 2/8, 3/8. And that leaves me with 5/8. So if the fuel was full before the journey home, what would the answer be? Well, if the fuel was full, I'd have 8/8. I would still use the 3/8, and it would leave me with 5/8. And let's see whether, if we used a different strategy, whether we'd get the same answer. So here's my bar model chopped into 8 equal parts to represent the 8s, and I'm simply going to take off 3 of these 8s. And this will leave me with 5/8 remaining. So if the fuel was full before the journey home, what would the answer be? Even using the bar model, we're still getting 5/8. But what about a number line? Would we still get the same answer? Well, firstly, we'd need to identify that the 1 is the same as 8/8, because 8/8 is a whole, and we're going to jump back 3/8. So 1/8, 2/8, 3/8, and that's going to give us an answer of 5/8. So no matter what method we use, if the fuel was full before the journey home, what would the answer be? We would get 5/8, whether we use a fuel gauge and simply cross off the amount we need, if we used a bar model to represent that amount and chopped off or crossed out the sections we no longer needed, or used a number line starting at the first number that we began with and counting back the amount that we need to subtract. All those 3 methods are going to give us the right answer. And now we've looked at those methods, now it's time for you to continue with the textbook questions and then move on to your independent work in your workbook. So remember with this, being able to count back, remembering that you're going to start with that fraction, and really you're working with the same denominator, you're working with like fractions, so you really only need to concern yourself with the numerator in this case, so counting back that amount. But if you create yourself that bar model to represent it, that number line to represent it, and count back in those unit fractions to make sure it's correct, you're going to be on the right track. So good luck with this, and I look forward to seeing